Welcome to qnawire.
This question we need to consider two different facts. First of all, let's remember that the overall equation for finding the delta G for a reaction is delta G is equal to delta G naught plus RT times the logarithm of the equilibrium constant. So in this case, if we are at equilibrium, we know that delta G needs to be equal to zero. So that leads to this equation that delta G naught is equal to minus RT logarithm of the equilibrium constant. I'm going to write down the equilibrium constant directly as K. So for this reaction, what we have is that the transformation x going into y is going to have a delta G equal to delta G naught of 20 kilojoules per mole. Now, if we write down the equilibrium constant, this is equal to the ratio of concentrations of the species y divided by the concentration of species x. So directly, we need to solve for k. Using this equation over here, we are going to notice that k is nothing but the exponential of minus delta G naught divided by RT. So now the only thing that we need to solve this is the temperature. In this case, the temperature that I'm going to use is going to be 25 degrees Celsius because that is the standard temperature. Since we are under physiological conditions, in different sources, the ranges of temperature can be from 20 to 40 degrees Celsius, or you can switch up the temperature to have exactly 36 degrees Celsius, which would be a normal human temperature. As I mentioned, this is going to depend on the professor and the sources that you are employing for this course. So I suggest you to just change the value for temperature for the one that is given to you, maybe in one of the other problems. So in this case, the temperature that I'm going to use as an example is 25 degrees Celsius, which is the same as 298.15 Kelvin. And remember that the gas constant R is equal to 8.314 joules per mole Kelvin. Mole times Kelvin. Now, we're going to simply solve this equation for K, and this is going to give us directly the ratio of concentrations of Y over X. So, the exponential of 20 kilojoules per mole. First off, we're going to put down a minus in front of it. 20 kilojoules is directly 20,000 joules per mole to make all of the units match up, divided by 298.15 Kelvin, multiplied by 8.314 joules per mole Kelvin. As you can see, the units are going to cancel out properly, joules with joules, Kelvin with Kelvin, and mole with mole. And the value for that exponential is unitless as it should be. So now the value for k is equal to 3.133 times 10 to the minus 4. And again, this is equal to the ratio of y divided by x. This means that we're going to have almost 10,000 times more of x of the reactants than of the products. So now, with this, we can continue with the second part of this question, this part B, that now the reaction that we need to study is the following one. We have X plus ATP plus water. It's going to produce Y plus ADP plus inorganic phosphate. Now, this reaction we can separate it into two different equations. X plus Y, X directly being transformed into Y with a delta G naught equal to 20 kilojoules per mole, and the hydrolysis of ATP. So we're going to have ATP plus water going into ADP plus inorganic phosphate. So for this reaction, the delta G naught is equal to 31 kilojoules per mole, but as a negative, so minus 31 kilojoules per mole. This reaction is spontaneous, right? So if we sum both of these equations, we're going to get that the total delta G for the reaction that we care about, for this one, delta G naught, let me make this G more as a G, is nothing but minus 11 kilojoules per mole. Okay. Now, this value for delta G naught is the one that I found online. Again, if you're employing a book or a different source, use that as reference to get the correct result. So we're going to do the same procedure. Now, the equilibrium constant for this reaction is equal to concentration of Y times concentration of ADP times concentration of inorganic phosphate divided by concentration of X times concentration of ATP. And the concentration in water doesn't enter into the equilibrium constant because it's a pure substance, right? And again, this is going to be equal to the exponential of minus delta G for the whole reaction divided by RT. In our case, now, this is going to be equal to the exponential of minus, in this case, minus 11,000 kilojoules per mole divided by RT. And it's the same values that I employed before, right? 298.15 Kelvin, and our constant, 8.314 joule per mole Kelvin. Sorry about the space in that section. And the result for the equilibrium constant is equal to, it's going to be equal to 84.57. And again, let's write it down as the concentrations that we have. So now in this problem, the additional information that we get is that the concentrations of ATP, ADP, and inorganic phosphate are equal to 1 molar. So what is going to happen is this is 1 molar, this is 1 molar, and this as well is going to be 1 molar. So the ratio will be directly 84.57. And this is equal to the concentration of Y divided by concentration of X. So as you can see, now we have more of Y than we have of X compared to our initial result. So that is what happens when we couple the hydrolysis of ATP to a biochemical reaction that is unfavorable by thermodynamics. You can make it favorable because of the delta G of the ATP hydrolysis. And finally, for part C, I don't have access to table 13.5. So the only thing that you need to do is substitute the values for concentrations here and solve for this ratio using the value for K that we have. So for example, your final result would be concentration of Y divided by concentration of X is going to be equal to 84.57 times concentration of ATP divided by concentration of ADP and concentration of inorganic phosphate. And you just need to replace the values over here. And that would be all. Thank you very much. Just remember, check out the temperature that is being asked of you. In this case, I just use the standard 25 degrees Celsius, but depending on the professor that you're taking or the book that you're employing, this temperature could be 36 degrees Celsius. So you just need to substitute that and plug it in into these equations. And that would be all. Have a good one.